So, hey, everybody, we're going to talk about how we can learn how to automate all the things, all the code and testing things with GitHub Actions. So, who am I? I'm Colby Fayok. I'm the Lund-hugging BB-8 and Kylo Ren over there. I work with the dev community as a developer advocate for Applitools. You can find me pretty much anywhere on the web by just Googling my name, as I'm the only one in the world. So, we're going to jump right into it. As developers, we have a bunch of tasks that we have to deal with day to day. Particularly, we're going to talk about code tasks. So let's see what some of those actually look like. Well, first there's linting. Linting basically tells you if you wrote sloppy code. But on a serious note, it can actually be really helpful for pinpointing syntax errors. It's also generally helpful for making all of your code look the same, which makes your code easier to read through and work through, especially if you're on a team. The problem is unless you're running a modern framework that runs it out of the box, you have to actually remember to run it. Formatting is basically linting, but it will fix all those issues for you. Your linter actually might even do it itself. But with formatting, you have tools like Prettier, where it will format the code and even include an opinionated configuration. Linting and formatting both come with a lot of super practical benefits, but you also benefit from not having to spend time in code reviews arguing over syntax preferences. You can let the robots be the bad cop and do it for you. There's less that you have to think about and less that you have to stress about. But again, your worst enemy here is actually being able to remember to run it. And even more critical to a developer's workflow is testing. While formatting and linting help prevent errors, it's more so static analysis. It helps you find the syntax errors, but it's not actually doing a lot to test the functionality. Tests help to make sure that you don't break things and end up losing a lot of money when your online store is down. The tests aren't just for your QA engineer to run every once in a while. You need these tests to be ran regularly. Otherwise, they're not doing their job. And finally, the last thing we'll talk about is deployments. Ultimately, you want your application to go somewhere. You want people to actually use your application. Deployments can be painful. For large, complex infrastructures, there's a lot of moving pieces. On top of this, you have to remember to deploy all those pieces. Missing one step could take your site down, and in a bad way, not just because you're deploying a new version and have a little downtime between migrations. A theme through all these tasks, though, are they're very important in one way or another. They help us focus on the real challenges of our work, not drama in a code review or stumbling through another deploy. But another theme is that they all require humans to do them. That means they're prone to human error, whether it's simply forgetting to run something or forgetting to include a particular step, even forgetting to do it in the right order. So what can we actually do to avoid those human mistakes? Well, we can automate it, of course. So let's automate all the things. But how do we actually automate all of the things? Well, if we're deploying anything even moderately complex, we have a bunch of things that we can typically have to do actually deploy our full stack, where these 10 commands or buttons you run every single time you deploy your Rails server and AWS infrastructure, well, we can put that in a script. Scripts are probably the simplest form of automation. This helps us to automate the manual tasks that we might have to take. So why not put them in a bash script or insert your favorite scripting language of choice? You can even write JavaScript in Node if that's your thing. The goal is to have a list of repeatable steps. And by using that one command with one script, you're able to do the exact same thing every single time. That way, you never forget to do anything. But scripts ultimately rely on something to trigger that. If it's still a human, you still might forget to run the script in the first place. Or if somebody is filling in for the day, maybe they won't even know that you have a script. A feature that comes baked into Git itself is Git hooks. With Git hooks, you can trigger something at different points in the Git process. For instance, if you want to set up a Git commit hook, where anytime you make a commit, your hook will run, automating some part of your process, where a good example is formatting. Anytime someone commits, you can set up Prettier or any other formatter to run before that commit is actually applied. With your existing scripts to run the linting and the formatting, this is called a pre-commit hook, where with tools like Husky, you can hook in and manage to do the Git hooks. We're also applying lint staged here, which allows us to get a path to all of those changes that were actually staged in Git. That way, when we run our pre-commit hook, it's not affecting the entire repository, only the files were changed by actually passing that as an argument into that command. But once that script finishes, those changes are added onto the Git stage before the commit is applied. So when the actual commit happens, all Git knows is that it's this pretty formatted code. All the developer knows is that they got their job done. And when the code is pushed up to GitHub, it looks like one single person wrote it. But not everything makes sense as a Git hook. You don't want your tests to run as a pre-commit hook, for instance. That's going to be a huge pain for developers. Imagine you're working on a project with a huge test suite. In order to commit, you have to run that entire thing. Nope. So we can take that to another level by running CI/CD processes. CI is continuous integration, and CD is continuous deployment or delivery, depending on who you ask. And while some teams still require these to be kicked off manually, that kind of defeats the purpose, where the goal is for CI/CD to be automated within your code processes. For instance, if you push a change to your main branch, that triggers a certain set of functionality. If you push it to a feature branch, that might trigger a little bit differently. Some popular frameworks for running these processes are Jenkins, Bamboo, Circle CI, and Travis CI. And depending on the framework, setup might look a little bit different, but most of them depend on some kind of configuration, but can have varying levels of actual scripting included within that. While this here is a simple example, I personally still have nightmares from working in Jenkins in past jobs, but I'm also primarily a front-end engineer. The DevOps team swore by it. I think mostly because of the flexibility though, not necessarily the ease. But setting up CI/CD can be super powerful. You can have large, complex orchestration of your entire infrastructure. Do you need to deploy some Lambdas or dump some static site into storage? Add a script to your CI/CD process. Need to spin up a VPC with very strict networking rules? Make Jenkins do it for you. Well, because you're using and leveraging scripting and the automation of scripting, you should really be able to accomplish anything you want. But like I mentioned before, I'm a front-end engineer. I struggled with Jenkins. It didn't have great documentation, at least at the time, and waiting for builds to finish took forever. For a lot of those frameworks, you also have to maintain servers. And did I mention that I'm a front-end engineer? I can spin up a node server, but I don't really want to deal with servers. Servers are so last decade, am I right? Kidding aside, I want something where I can actually easily plug and play, something close to the rest of my code that I don't actually have to fight with. And after all that build up, that's where GitHub Actions comes in. GitHub Actions are still technically a CI/CD, but in practice, they feel so much more approachable. The best part is they can be just as flexible. With Actions, you start off by setting up the environment you want to run in a workflow file. You add whatever commands that you want to run, when you want to run them, and you're off. For instance, if I wanted to simply run some tests, I can set up a test file to run on Ubuntu or a variety of other options. Then I can check out the code that I'm currently working with, where I'll be running commands inside of a working directory. To set up Node, I add another action where I specify that version. I can even make this workflow work on a few different versions of Node from the same file. Then finally, I install the dependencies and run the tests. This alone will run my tests anytime a change is pushed or if a pull request is created. As they run, they show up right in line with the rest of the pull request, letting you know just by a quick look if the proposed changes break things or not. This helps set up a really great feedback loop for developers, where if something isn't working, they'll get that feedback very quickly. I could also use GitHub Actions to deploy code. Once I install my project dependencies, I can build that project, then configure my AWS credentials as secrets, and I can then sync those artifacts up to AWS to deploy. The AWS CLI is actually available by default, which makes this really easy to do. And this really includes any kind of commands with the AWS CLI. And I can even use actions from the marketplace. Like if I wanted to post a message to Slack when a new pull request is created to my personal repository, I can use the post to Slack action, which I can configure with my project to send a note directly to Slack. It's a helpful way to automate the little parts of a development workflow. These last few were just some simpler examples though. But if it goes to show, all we need is a few lines where we can really do a lot of different things. The cool thing though is we can take this up another level. We can create our own GitHub Actions. Once you create a custom GitHub action, you really gain the flexibility to do whatever you want inside of that controlled environment. You have a few different options like running JavaScript with Node or running with Docker, where you really get the ability to do whatever you want. For instance, if I have a common task that includes a bunch of complicated things, I might not want to have to copy and paste that same snippet between every single repository. I can set that up as a node script and that script as a new action. That way, I only have to make that one reference between all of my different projects. And that's exactly what I did with my Applitools Eyes GitHub action. Just to add some really quick context, Applitools is a visual testing platform where every time you run a test, Eyes takes a screenshot of your website or mobile app and compares those images with AI. To do that, Applitools has a ton of SDKs, whether Cypress like you see here, or Selenium Java, or really any popular testing framework that allows you to drop it into existing tests. This is already pretty easy to do, but I wanted to make it even easier. I wanted a solution where somebody who might not even have any testing set up could easily drop some automated visual testing, which is where we come back to the Applitools Eyes GitHub action. Let me enhance this. This action just takes one snippet. You have to plug in your API key, which is required anytime you want to run a test with Applitools so that it's associated with your account, and then you provide the URL that you want to actually test. Once that action starts off, it kicks off a process where it first crawls the URL that you pass in. It does a similar process to what you would expect Google to do with its robots, where it clicks around the site, tracks what links are available for your site, and puts it all in a list. You could even pass in your own custom sitemap URL if you'd rather. But to crawl, I use a package called Sitemap Generator, where I can run a simple command and I have a list of the URLs that I need. Once I've collected all the site details and the configurations, I can run Cypress right inside of that node script, including those URLs from the sitemap as an array right inside of Cypress, which allows me to collect all my results that I can use for later, such as failing the action if the test fails, or generally working with the results for a better developer experience. But finally, Cypress runs those tests as it normally would, giving me my test runner and my results for the Eyes check. The only difference being that it's looping through all those pages to check from the sitemap. But that gives me my test runner and my results for the Eyes check. With those results, I can comment right on the pull request what's passed, failed, or unresolved, giving the maintainer of the project an easy way to know if the code introduced a bug, or at a minimum, introduced a breaking change. I even figured out a solution where we can plug into an existing Netlify workflow. If you're not familiar with Netlify, they'll automatically deploy your static application straight from GitHub. This happens anytime changes are pushed to your default branch. So I was able to find an action where it actually waited for that deploy to finish, and it stored that URL as the output of that action. And I passed it right into my action, which did its thing. It's crawled its site and performed the visual testing with Applitools. But the entire project is ultimately a script that I need to run. We're running it between projects is really just a few input parameters of a difference. Instead of having to make sure a testing framework is set up, along with installing the SDK and writing visual tests, this makes it really easy to add Applitools Eyes visual testing to really any project with just a few lines. So let's actually see what actions look like in practice. Let's do a quick walkthrough. So here's what we're going to go through. We're going to walk through this custom action, this GitHub action that I just told you about for Applitools Eyes. Then we're going to notice that it's going to take a little bit of time to finish. So while we wait for that, we're going to then show some Jest tests that I have prepped, where they're just really simple to kind of show what's going on. And I'm going to set up a new GitHub action through the GitHub UI to run those tests, to see how it works when it's actually running on GitHub. And then I'm going to break those tests so we can see how that actually impacts our workflow. So I'm going to go ahead and switch my screen here where I can start my demo. Okay, so you should be able to now see my screen where right now I'm on we're going to start off by running that Eyes GitHub action. And what I have here is actually a completely empty repository. I can refresh and I can show that it's a completely blank repository. But what I'm going to be able to show you is you can really add this action to any single project that you want. The only difference is how you pass in that URL, whether it's that Netlify option like I showed before, or some kind of custom script to grab that URL, or if you just want to statically pass in a URL and have it run on its own. So to do this, what we're going to do is we're going to first go to this Actions tab right inside of the GitHub UI. And what it's going to do is, because we don't have a project set up, typically it'll give you suggestions based off of the type of project, such as Node.js, or maybe you have a Ruby project. But here, we're going to just set up this simple workflow. Now, when GitHub opens up this page, notice that there's a lot of comments, and for our purposes, that probably makes it a little hard to read. So I'm going to start to delete these as I'm walking through it. But as we can see, starting at the top, we have our name. And how about we call this visual tests? And then we have this on parameter or property, which this is going to be where we're actually triggering our action workflow. So right now we have it set up so anytime changes are pushed to the main branch or a pull request is created from the main branch, it's going to run. And we additionally have this workflow dispatch event, which is really just a way to be able to manually run those tests from within the GitHub UI itself. But then we go down to the jobs section, where the job sections is going to be actually where we define what we want to happen. We're starting off, we can name this, and let's call it visual tests again. I'm going to get rid of the comments. But we're seeing that this is run on Ubuntu latest, where we're then going to hit the steps for what we're going to actually do, where we're going to currently, it says we're going to check out the code, we're going to run this simple script, and then we're going to run a multi-line script. And of course, this is just a little template to show how these things work, but I don't really need any of this for what I'm trying to do. All I want to do is anytime that these changes are pushed, I want to run my Applitools eyes GitHub action. So I'm going to go ahead and I'm going to go to my Applitools eyes action repository. And if we scroll down, we can see the snippet that we need to paste in here, where I have these steps. It's all we need to do is use this action from the repository. We just need to pass in our Applitools API key, our base URL, and we're off and ready to go. So I'm going to take that, I'm going to paste it right inside of this action file instead of what was already there, make sure that my indentation is actually properly correct, and we're good to go. Now, the only other thing that on top of this is if we see here, I have this secrets Applitools API key. And over in the settings tab of your repository, if you scroll down on the left-hand side of the page, we see this secrets section, which this is where you're going to have to actually load your secrets. And as we can see here, we don't have any secrets actually enabled right now. So I'm going to go ahead and load one of my secrets that I already have available for my Applitools account, where I'm going to go ahead and log into my dashboard. And if we head up to the top of this page, over inside of our user here, we're going to click that, and we're going to actually be able to see, I need to get rid of the Zoom UI, where I can click my API key, where I have this API key that I can copy to my clipboard, and I can paste right as a new secret inside of this project. I'm going to name it Applitools API key, where we then have our secret, where we're then setting our environment variable to be able to use within the action, where it's going to come through, it's going to pass that in from the secrets repository. But now all we need to do is commit that file. And as soon as it's committed, we're going to actually see that we can go to the Actions tab, and we already have this visual test workflow that we created, and we can see that it already started up. Now, as I mentioned before, this is going to take a little bit of time because if you remember, it's going to actually crawl through the site where it's going to run the visual test. And I think I actually didn't run it on the entire code base. So I'm going to go ahead and make one more adjustment in here where by default, we're only going to run on the top level page as the depth parameter of 1 to avoid somebody accidentally running on a huge site. So what I'm going to additionally do here is pass in the max depth parameter and set that to 2 so that it clicks the links and goes to those links so that we can get visual tests of all those pages. And I'm going to simply commit that in. Now, once we do that, we're going to be able to see that not only do we have this first test that's still running, I can actually cancel that out, but we're going to have the second test that automatically kicked off because we pushed new changes to main, where it's going to now run those visual tests for us. Now, we're going to come back to this in a second. So let's head over to our Jest test, where we're going to walk through how that particular set of tests work. Now, I have this existing repository that I actually created for a tutorial that I set up, where it's just some simple Jest tests. If we look in the test directory and go to lib particularly, we can look at this orders.test.js, where all this is really doing is it's pulling in this one function and it's running a test just to make sure that it's validating that it's calculating those order totals. Now, this is just a kind of proof of a concept application just to kind of show how Jest works, but it's really just showing that we have a working test that we can actually start to run inside of our project. And just to prove that the tests are currently working, I have my terminal up here. You can see that I even ran yarn test to test that out. I can run it again. And we can see that those tests are working properly and ready to go. So the first thing we're going to do is we want to set this up as a GitHub action, similar to what we did for the Applitools action, but it's going to actually be tied to those commands that we actually ran locally. Now, what I'm going to do, just like before, is head up to the Actions tab. And we can see here, as I mentioned before, because it's a node project, it's going to actually suggest those different workflows for us so that we have an easier time setting that up. So I'm going to take this Node.js workflow and I'm going to click set up this workflow. where it's going to similarly give me that file just like before. I'm going to start to rename this. Let's call it test.yaml and tests. And we can see, again, it's triggering on both a push and a pull request in the main branch. It's running on Ubuntu. This time, as we mentioned inside the talk, it's actually running on multiple versions of Node, which is a great thing because it's going to be able to go through and make sure that it's working on a variety of different versions, not just maybe an older version or newer version. But we can see as it goes through, it's going to check out that code. It's going to use Node.js. Now, as we saw locally, I used Yarn instead of NPM. So the only thing I'm going to do is switch this to Yarn. But we see by default, if you're using an NPM project, it gives you NPM CI, it gives you the build if it's actually present as a script, and it gives you the tests. So all I'm going to do is change this to Yarn install. I'm going to actually get rid of the build step because I don't need that. And then I'm going to change it to Yarn test. I'm also going to get rid of this caching mechanism because that only applies to the actual NPM tool, which as we were talking about, we're using Yarn. So that's literally all we have to do in order to get our tests running. We can see by looking through the workflow, anytime these changes are pushed or created a pull request, we're automatically going to go through and run these tests. So let's go ahead and commit this. And we can see, just like the other repository, if we go to the Actions tab, it's already starting that test. And this time it's going to be quick because all we have is that 1 or 2 tests that's going to run. And it doesn't really need to spin up a heavy environment in order to actually get the test running. So we can see that it's going to start going through, and we're actually running it on all of these different Node versions. We can see right inside of the sidebar, we can see right now we're running Yarn install, which just like you would do locally, it's going to make sure it's going to install all the packages and dependencies needed for that particular Node project, where then as soon as that's done, we're going to hit the Yarn test command, where we're going to just give it a second here to finish up. We can see it went through, and we have both tests passing. We have all green check marks, and it looks like it ran successfully on all versions of Node, which is expected because they were working locally. But we can see that we successfully ran those tests inside of GitHub Action. So now what we want to do is let's break this and see what happens when it actually fails. So I'm going to go over to my code tab. I'm going to go to the lib directory, and I'm going to open up the orders file that actually includes that test function that I was talking about. So I'm going to edit this right inside of the GitHub UI. And how about I'm going to remove this quantity variable right here, where instead of multiplying the price by the number of items, I'm just going to say one single price, no matter how many items, to get tacked onto the subtotal. And of course that's wrong, but we want to see this break so that we can see what this workflow looks like. So I'm going to scroll down, and I'm going to actually commit these changes, but I'm going to commit them to a branch, because what I'm going to do is create a pull request with this. Now I'm not going to fill any of this out as it's not important to this workflow, but I'm going to go ahead and click create pull request. And as soon as I do, we can see this section right in the middle here, where it's immediately going to say that it's running through all those different tests, which are checks inside of the GitHub UI. So we have our node 12, 14, and 16, just like we just saw ran, but it's going to run those on this particular change set that I made inside here, where I intentionally tried to break it. So let's see if it goes through and finishes, and see if it's actually going to give us some kind of result for how this is actually working in practice. And as we can see, it's already starting to fail. So let's click into this and see what happened. So if we click into the details of this node test, we can see here that it's telling us exactly what happened, where we have these failed tests, and it's exactly what we expected. It's because it's a lower value, because we weren't including that quantity variable. But now, because we have that actual failure right in line inside of that pull request, so that when the developer or maintainer comes back to this pull request, they'll know that these tests are failing and this code isn't necessarily valid, or at least the test needs to be addressed if it is a breaking change. So this is a really helpful way to get a great feedback loop right inside of our projects. So this is the basic example of using Jest. But as we mentioned before, let's check and see if our Applitools visual test is actually finished. So I'm going to head back over to that first tab, and we can actually see that everything is finished running already, where we have 3 passing. And this is just the output of Cypress running through all my different checks that happens in the background inside of the Applitools GitHub action. But what I'm going to do is I'm going to go back to the code tab, but what we want to see is going to applitools.com, and I'm going to again log into my account. But this time we can see at the top left of this page, when this loads, we have this new GitHub action workflow where I have all the pages that were actually scraped inside of the page, where we have this demo application. We also have the app, what happens when you click the login link. And while this is just a demo application that was meant to serve as a way to show these visual tests, this shows that it went through, it clicked all the links, and it was able to find all the pages and create that sitemap and gave us a way to see the visual differences or create the checkpoints and baseline in this instance for future tests, where every time a change is pushed to the main branch or a pull request is created, we're going to validate against these baselines to make sure everything is working as expected. Cool. So I'm going to head back over to my slides now. Let's see. Zoom is going to let me change this. Okay. Are we back on my slides? We should be back on my slides. Cool. So let's recap here a little bit about what we achieved. Well, we first saw how easy it was to set up a new GitHub action to run against our existing tests. We saw that we were able to work right inside of GitHub. And we even broke our test to see that we were able to let us know what was failing and where it was failing right inside of that pull request. So before we actually wrap up, let's check out a few other examples of GitHub Actions out in the wild. I also created this other GitHub action that I created as a template called Content Reminder. One of the things that I struggle with as a content creator is simply remembering to share all of my old content, all my educational tutorials. So I put on my developer hat and I did something about it, where I built Content Reminder out as a GitHub action, where it's simply a node script. But what happens in the node script is I run it on a cron instead of the actual GitHub event, so that it triggers 2 times every single day. With Actions, not only can you run it using GitHub events, but you can use that same old cron syntax that you're used to for actually scheduling these runs. But once it runs, I run that node script where I look through a few different RSS feeds of my content and find a random entry, where then I send myself an email with that content using SendGrid, pushing me to share it out to the world. For another practical use case, performance is or should be at the top of everybody's mind when building web applications. Lighthouse is a fantastic tool from the Google team that helps measure performance. And the Lighthouse CI action lets us drop in those measurements right into our GitHub projects. Not too different from my Applitools action, we can pass that URL right into the Lighthouse CI action. We can also define a performance budget, such as the maximum page size. When Lighthouse actually runs, it'll take that budget into consideration when determining the results. And if it finds any issues, it'll add annotations right inside of GitHub, letting us know what the issues are with our projects. Now, bringing things to the real world, Alfonso created Issuetron 3000 for a GitHub hackathon. Whenever a new issue is created, Issuetron 3000 will run to send a signal to an IoT device. And while I admittedly am not familiar with the IoT world, setup is very similar to any other action, where there is extensive documentation such as how to actually figure this or configure this thing. Well, ultimately, it's going to run a script that Alfonso set up inside the action, where it sets up the MQTT client. Again, not my world of IoT, I don't understand it, but it sends that payload like a normal request, depending on the event. And once it's received, Issuetron 3000 is activated and it blinks or lights up based on that action configuration. And it works really well if you look at the video that's inside. I'll include a link with my talk notes. And finally, if that last one wasn't considered fun, here's a little bit of some, where Tim created a community chess game on his GitHub profile page, powered by GitHub Actions. To make a new move, anyone could click on one of those links to a specific space, where all it's doing is it's opening up a new GitHub issue with that location in the title. Once that action sees the open request, it ultimately runs a Ruby script to set up the actual play, including actually parsing the title for the next move location, along with a ton of other stuff that I'm not showing here, as well as updating the README with the actual new move, where ultimately, if your move is accepted, it will show up on Tim's profile. And if you're persistent enough, you might even show up on the leaderboard. But whatever you do with Actions, the goal is to automate as much of your code tasks as you can. Again, let the robots do the hard work and be the bad cop. Spend your time on the unique challenges of your project. The great thing about Actions, though, is that it makes it approachable for anybody to use. I no longer get stressed out when working on CI/CD workflows. I love setting up a new action and figuring out what I can automate. I get excited seeing something run automatically that I no longer have to do manually, and I'm sure you will too. If you want to learn how to create your own GitHub action, or if you want a quick intro on getting started with actions, I have a ton of resources, including an egghead course and videos on YouTube. And if you want to just learn how to go from end to end, from design all the way up to a full stack Next.js app, including automating all those code tasks with GitHub Actions, check out my free course on YouTube, where you can find it at fromdesign2.dev. And that's it. If you want to learn more or chat about the talk, don't use that link there, as I forgot to swap it out. But you can find me everywhere at Colby Fayok. Also, tweet out some of the stuff that you've seen here today. Thanks, everybody. Jessica, yeah, I'm excited for you to try them out. GitHub Actions was kind of mind-blowing for me. I have a lot of fun, of course, with them, trying to automate whatever I can. And I'm excited to see what you're able to come up with. Yeah, Bitbucket. I actually have never used Bitbucket before. Maybe they have something similar. I know other Git providers do have some. Like, I know GitLab has its own kind of CI tool that it has. So maybe Bitbucket has something. Yeah, sure. So Lighthouse is, I'm not sure if maybe you've heard of the Web Vitals, which are different attributes about a web page that is attributed to performance. Google worked on this Lighthouse project, which isn't necessarily a GitHub action itself, but this GitHub action that I was talking about uses the Lighthouse tool in a way that it's able to actually collect those results. And what it's able to do is it grabs a lot of identifiers about how your page loads. Things like, how long does it take for the entire page to load? How long does it take for that first byte to actually come in from the request? A lot of things that help to determine what kind of user experience you're actually providing by the performance of your application. So it's a really powerful way to kind of get those metrics. And it's a really great tool. If you go to web.dev, it might be /test. They also have another tool where you can actually get some of those results by just simply pasting into your URL. There's a lot of great things about Lighthouse. I definitely recommend checking it out. If performance should be on everybody's mind, as I mentioned, but if that's something that you're interested in looking into.
All right, last call for any other questions, guys. These have been really good.
Yes, GitHub Actions can be triggered by issues. I think it can be triggered by really like any kind of GitHub event inside a repository. There's a ton of flexibility in there. You can even set up webhooks if you need something absolutely custom to trigger it. So there's a lot of great ways for you to be able to use it. One fun thing that I created, for instance, is whenever a pull request is created, I comment a GIF saying thank you on the pull request. And you can do something similarly with GitHub issues. Really, it's just because at that point you can run a script and then you have access to the GitHub AutoKit API, you can really do whatever you want when kind of interfacing with that repository. Well, if nobody else has any questions, again, feel free to reach out to me at Colby Fayok if you end up having any questions later, or if you just didn't want to ask you here. More than happy to try to answer your questions or help you out through getting started.